sulfur oxides, what we call SOx. So the biggest problem with smelting is the air pollution, especially SOx. This is compounded by the fact that many smelters use coal as the heat source. And remember that when you burn coal, you again release a lot of SOx. So you get SOx from the most common heat source, coal, plus SOx from heating up all the tailings to release the copper. Are there any questions about smelting?
What releases more SOx, coal or the rocks?
I would guess by unit weight, coal would release much more.
What's an alternative, like with less air pollution than coal, that you could use? Wood?
For less air pollution, you could use, I'm guessing, natural gas. Petroleum, you could use filters to remove some of those pollutants before they reach the atmosphere. I guess you could use nuclear heat. I don't know how you would plumb all that, but just making it up. But for even less air pollution, you can do number 2, which is called heap leach extraction. Look, they sell me a little kit right here. So I can use some of this copper stuff. And some of this acid that they sell me. And you can pour the acid on the copper stuff, and it will dissolve the copper from the ore. Then you can run that stuff through a filter, and you can trap all the copper. It's called heap leach extraction, because you make a heap of ore, pour acid over it. Sometimes people use cyanide. And that causes the resource to leach out of the ore. Then you filter it to extract the resource, leaving some tailings that were washed by the acid or the cyanide. Good news, bad news. Hold on a second. Good news, if you were doing this in a lab setting with like controlled environment and good lighting and lab coats and dust masks and stuff, that would be perfectly clean, perfectly controlled, and very effective. Bad news, in industrial scales, we don't usually have that successful control. So the problem here is leakage of the acids and cyanide. When you put the tailings back in the ground, they often have some funk left on them. When it rains on your big piles of tailings, a lot of this washes into surface water. First and second.
What kind of acid is it, generally?
Sulfuric is a very strong one, and it's not very expensive because it's an industrial pollution, like power plants make a lot of this. So I'm guessing that sulfuric acid is one of the major ones.
And does that not burn through the filter? Or is that just a filter you found?
Yeah, this is a filter for this sort of example. I'm guessing that at the industrial scale they have different filtration methods. Yeah?
Would you be able to use the acid runoff from mines to do that, or would it not be strong enough?
I reckon you could concentrate almost any acid. You can evaporate the water out. So if you can contain industrial acid pollution, you can usually reprocess that into another industrial application. Yeah. Big problem with heat extraction. Easy to control in a lab setting. easy to have spillage and leakage in industrial volumes. Questions about that? Finally, how many of you have silver fillings? I mean, most of you have ceramic fillings, right?
Like 90s.
Right.
I had a silver too.
Your mommy and daddy, how many of your mommies and daddies have silver fillings? Like your mommy and daddy, when I got my fillings, because I grew up in a different country, less developed country, and because I lived in this country during the late 1980s and the early 1990s, I've got a ton of silver fillings. I have horrible cavities. I've had probably more than 40 in my adult life. I have 7 crowns over 6 root canals plus a partial. And I'm missing a couple of teeth.
Jesus. Halloween every day.
I have, first of all, a sweet tooth. Second of all, I didn't brush my teeth when I was little. Third of all, I have a genetic predisposition for weak enamel. So me and my mom's side of the family, we have, like, there's a way to rate your enamel density. I'm like right next to 0 on that scale. Like rock bottom of enamel quality. So I've been to the dentist like you would not believe. Every time I go to the dentist, I'm like, okay, which teeth do you want this time? I'm done taking care of them. I told them from now on, just take them out. Yeah, no, I lost my, I gave up on my first tooth last, about a year ago. No, I'm done. I'm over it. Yeah, I told them I'm done. I don't want any more teeth. Screw it. I'm not trying. No, I wasted so much money.
How's your wife feel?
Good. She doesn't need my teeth for anything. I don't need my teeth for anything. In 1 year, I wasted 16 grand at the dentist.
You brush your teeth?
You get grilled. You should get grilled.
That's before I became a teacher. It's one of the reasons I became a teacher, because insurance is very helpful. I'm actually, they started putting ceramic crowns, and I realized, no way, I want gold! Because like someday, if I'm stuck in like India with no passport, I could be like, all right, what do you give me for this tooth? Like, all right. Life lessons pros and Caballero. First one's free, kids, then you gotta pay. All right. When I went to the dentist a long time ago, they would go, and would drill out all the rot, and then they go, and they would shake up this little tiny jar in a little paint mixer. You ever been in the paint store and they mix up your paint can? They go, and vibrate the paint can and mix it. So they used to make little miniature ones of those that would be on the countertop of the dentist office. And they'd get these little tiny jars that had like silver powder and mercury. And they'd go, and it would vibrate, so it would all mix together inside the jar, and then they'd go, and they'd scrape some of that out, and they'd go, and they would squeeze it into the hole. And because it's a mixture of powdered silver and mercury, when you chew, it packs into the hole. And because mercury is so flexible, it's a liquid at room temperature. It's the only metal that's liquid at room temperature. It keeps the bacteria out of the hole. It's a pretty good way to plug your cavities until sooner or later the mercury starts sweating out and you eat it all and it dries out and it falls out. Nowadays, they figured out some fancy ceramic plastic thing for your fillings. So all your fillings are white and very difficult to see. But my fillings, if you can still see it now, mine are silver. We call that stuff amalgam, which is, you should know, a mechanical mixture, a blend of different metals. Yeah?
But they're not actually chemically bonded.
They're not. It's not an alloy. It's an amalgam. So they just blend Mechanically, it's a physical blend, not a chemical bond. And this can be used to separate gold from ore. Remember I told you that in the tropics there's a lot of mercury pollution in the water, and as I'll explain why later. This is why. You take gold ore. You might want to write down the steps. It gets confusing. So you take gold ore, grind it up into a powder, mix in some mercury and some water, and stir. As you stir it, the mercury sticks to the gold and sinks, because that's a very heavy mix. Mercury plus gold is really heavy. So as you're stirring the barrel, the mercury drags the gold to the bottom of the barrel. You keep it stirring, and then you go, aha! And you pour out all the sand and all the water. And what you've got left at the bottom is a big glob of mercury with gold in it. Mercury is a liquid metal.
Wouldn't there be other metals in it?
There would, depending on the impurities. Yep. Yes?
Does mercury just like occur naturally, or is it always like
Mercury does occur naturally. It's also mined. It's used for a lot of industrial processes. It's surprisingly common in our world. We just don't usually see it because we don't like it to get into the environment. So it's a very controlled but very common industrial ingredient.
so like seeps out of the rock or something?
I don't know how it's mined. That's a very good question because you would think it would just pour out. Yeah.
Two questions. Was it more expensive to get the like gold or silver fillings in ceramic now?
I don't know.
And then also, how is methyl mercury made? Like, how is it different than just what you find in the ground?
The mercury found in the ground is what's called elemental. It's just mercury. Methyl mercury has been quote unquote methylated, which means a carbon group, CH3, is attached to the mercury atom, and that usually requires a biological process. So there's in-between steps to that. There's this to something else, which is replaced by something else, and then you lose a part and you're left with methyl mercury.
So it can be made in a factory like the one that was dumped into the bay.
It can be made in a factory. Once you've got your mercury and your gold stuck together, all you got to do is pull off the mercury and you've got all your gold out of the ore. It's very simple. You either heat it up a lot to gasify the mercury, or you use other acids to separate them and then you pour it in the river. You should know. Please look up. Mercury amalgamation has a big old red star because it's grossly illegal. You're not allowed to do this. It's internationally banned. But if you're already doing illegal mining, that often has illegal or even human slave labor force that was never permitted by the government in the first place, on land where you're not supposed to be anyway. You've already broken like every other possible law. This is still cheap, and it's still effective, and it's still portable, and it's still fast. Why not? Why is it illegal? Because all that mercury can only go into two places. Into a liquid dissolved form with nitric acid that's almost always surface dumped into rivers, or cooked off into the atmosphere, where the heating makes it very likely to methylate. No, turning into methyl mercury. Yeah, you can't turn one element into two other elements. You don't turn mercury into methyl. Methane. But methylate is when you attach methyl. You stick it on. How many of you have been to a place in Santa Barbara called Red Rock? If you walk up the river about 4 miles, there's a big sign right next to the river that says, "Catch and release fishing only, trout unsafe for human consumption." Because about 5 or 6 miles up the river from Red Rock used to be an old gold mine, And that old gold mine used mercury amalgamation to separate the gold back when it was still a common method like 100 some odd years ago. And so that segment of the river is heavily polluted with mercury.
It's Kevin.
Is that me? Whose device is making that sound?
Yours. What the fuck?
Is that my iPad?
Yes. It's ringing.
That's really bizarre.
It sounds like a horror song.
Oh!
Answer it.
I got it. Tell them that somebody forgot their phone in my room.
Yeah, you didn't do
Too late?
Yeah.
Can I turn that off?
Call back.
Are there any questions about those three types of processing?
So the smelting one is the reversing the process?
Smelting is melting. You melt out the metal from the rock. So today's warm-up is the way that I'd like to introduce our disposal issue. If we finish talking about mining, then we've entered the other chapter of our unit, the disposal. Remember I told you there's two halves in this unit, taking stuff out of the ground and putting the trash back in the ground. I don't know, dude. All these things are written on paper somewhere. It's called a study guide. So, let's start with the definition, today's warm-up. What is e-waste?
Garbage can on your computer.
Electric waste. Number 19, by the way. And any electric waste means something with a wire or a battery. I think you realize that our economy today is largely driven by the consumption and very rapid disposal of electronics. We throw them out all the time. You can buy like 10 flashlights for $5 at Costco today. Those have LEDs and batteries and metal housings, and they manage to make money off it, 50 cents a piece. How is that even possible? Computer ownership today is very closely tied to economic activity and education levels. Cell phone ownership today is slightly less economically dependent, and the growth in cell phones is almost all in the least developed nations. How many of you have ruckused a phone in the last 12 months? Made it in the garbage. Ruined a phone. And how many of you have ruined a phone in the last 24 months? Has anybody not ruined a phone in the last 3 years?
Does this count? It works.
You can see that's pretty rare. There are 6 students in the room that failed to ruin a phone in 3 years.
And what is the
In 3 years, I've ruined 4 phones.
Does this count if you...
Wait, is that like when you jump in the pool with it in your pocket and then go like that?
Yeah, that counts.
That little thing in the left detects moisture. That's voice warranty.
This is a really fun conversation, but anyway. First of all, you should know electronic waste is very dangerous because there are a bazillion different ingredients, many of which are toxic. if they get enough into your body or into your food stream. We have heavy metals, plastics, and adhesives, all of which are differentially bad for you. Now, it really stumps my students when I say, what's the problem with metals? Because our environment is bathed in metals. You drive in steel and aluminum to go to the restaurant where they used iron and copper to cook your food that was packed in tin, and more aluminum. You drink beverages out of aluminum. You wear jewelry made of platinum and gold and silver. And so when we think of metals, we just think those are all fine. That's because we figured out early on which metals wouldn't kill you, and we use them a lot. Recently, though, we figured out a lot of the other metals, the ones that do kill you, they make really good thingamajiggies and whatchamacallums for electronics. So a lot of our electronics, if we were to just throw them in the landfill, would cause really nasty pollution to leach into groundwater, surface water, soils. A lot of that can enter the food web. So instead, we, quote unquote, recycle our e-waste. Keep in mind, anybody know what a 4S costs? This is one of the big ones. This is the 32 gigabyte one. What did that cost? It came out a couple of years ago.
$400. When it came out or now?
$325.
When it came out?
300.
600.
Yeah, I think it was 6, right? $5.99? Yeah. And I got mine as a trade-in. I was due an upgrade by AT&T. I've been an AT&T customer forever. They owned me by the... And so I took it back. And so I think I only had to pay either $100 or $200 for the upgrade. But if you do some research, you'll realize that the price of this cell phone is about 20% materials, about 50% labor, about 20% profit for AT&T and Best Buy and Apple, and about 10 to 20%, I didn't make the numbers add up, about 10 to 20% marketing, research and development, branding, packaging, shipping. We call them the retail share. Sorry, the wholesale share. Of those materials, if we assume that this was $600, my hunch is it's somewhere in the ballpark of $150 material cost. The glass and the aluminum and the whatchamajiggies and the whatchamacallums and stuff. And when I'm done with this, when I sit on it or when I drop it, what could possibly go wrong? It's a $600 computer wrapped in glass. So I drop it and it breaks and I go, oh, dang it. Whatever, I'll get another one. Because I'm rich and I'm due for an upgrade or whatever. You would think, well, for $150, those are useful parts, right? Somebody should probably undo the screw and undo the other screw and pull apart the sticky and hammer the whatchamacallit to get the thingamajiggy out. And I could put these into little baskets and I could sell them and go, hey, Apple, look, I got you a whole bunch of whatchamajiggies and whatchamacallums, and you could probably reuse all these. There's a little bit of gold, a little bit of silver, a little bit of platinum, a little bit of mother. All those different metals and plastics should be reusable, right? But the problem is, remember that it cost about half the price of the item to put it together in the first place, and most of that assembly is not supposed to be reversible. So to disassemble cost almost twice as much as it costs to assemble. My hunch is the assembly fee was about $300 total. Disassembly perfectly would probably be double that. Yeah?
Do you think it's that much to create it? How does it get a huge market? Like it costs like $50 to
No, I know that AT&T loses money on them for sure. I know that Apple makes a little, but not very much on the item. They make all their money on the App Store, and on the branding, and on the deals with other distributors and stuff. But hey, dude, if you give me right numbers, I promise I'll deliver them. I'm shooting from the hip, and I think I'm kind of right-ish. If you're a writer, I'm willing to be wrong right now. My point is that it's not worth enough to take it apart. So when we e-recycle these things, how many have seen e-waste recycling things at like Earl Warren and like wherever they e-waste recycle? When we do e-waste recycling, most of this stuff ends up in growing economies. So for a while that was China, then China got over it and went to India, then India got over it and went to Pakistan, then Pakistan got over it and it all went to Bangladesh, then Bangladesh got embarrassed by the international community. The last 5 years it's mostly been going to Nigeria, but I think we're just getting to the point where Nigeria has better economic opportunities, and so I'm pretty sure it's going to ship to another country right around now.
Does this help the economy?
Well, in a way. Because when you think of e-waste recycling like me, you probably have a very ignorant fantasy of people with lab coats and dust masks using fancy tools in a well-lighted environment with big vents and like workbenches and conveyor belts and baskets and plastic gloves. But instead, about 5 days after you drop off your old monitor at Earl Warren, it'll show up on some dockyard in Nigeria. They take it out of the container, they lay it out on the ground, and they go, old TVs for sale, old TVs for sale. And most of them are either auctioned or sold off at a predetermined rate. Gabe picks one up for $5. Maddie picks up 6 of them for $25, so I gave her a bulk deal. They cart these away to their house, and then they go, hey, little brother, take the hammer and break the glass and pull out all the magnets and see if you can salvage the screws. We can sell them to the screw lady, and then take out all of the copper. We can sell it to Copper Dude, and take out all the little pieces of gold from these whatchamajiggies that if you get them to 600 degrees, I'm just making up the number. Get to 600 degrees, they'll sweat a couple of drops of gold. You can take them to what's-his-face, and he makes gold jewelry at home. We take out all the plastics, and we'll sell them to Homegirl, who has a hookup with somebody that recycles plastic. You take all the motherboards and take them to her house, and she's going to melt them. And when you melt all the motherboards, you can float off all the plastic and then harvest all the solder. And then her bro uses all that solder to make fake iPhones.
You make fake ones?
Yeah. The bottom line is, most of the e-waste recycling just becomes waste. And unlike the United States, where most of our landfills are at least somewhat designed for this, in most developing economies, the quote-unquote landfill is actually just an open-air dump. Now, you should recycle your e-waste. It's probably still better than the alternative. But you should realize that e-waste has a dirty little secret. It's not quite as sustainable as we'd like it to be yet. Internationally, we are moving towards standards of how we handle the nasty stuff. Internationally, we're trying to certify e-waste recyclers to make sure that they offer dust masks and lighting and stuff. But globally, we've been embarrassed for years by exposés of our e-waste ending up in communities where young people, because they have little hands, And because in many parts of the world, the children help their parents make a living instead of waste their parents' living, here you're all like the beautiful, exceptional child, and we give you your boob job at 16 and your car at 17 and send you to college. And we work extra jobs so you never have to dirty one little fingernail. But globally, children are required to be a part of sustaining their family. They have a duty to help their family. And most of our e-waste ends up in somebody else's wok that they're going to make their dinner with, or picked apart by kids in the living room, or piled up in the backyard where the chickens eat the funny colored stuff and they get tweaked eggs to make bad omelets or something. Remember that the goal is to make recycling better, not worse. In the United States, now that we do have some certified e-waste recyclers, like there's a company in Ventura who's like a world leader in e-waste. When you go over there, they'll tell you, look, we follow all OSHA-approved regulations, and we got all the lighting and the ventilation and the training and the tools and the lab coats and the gloves. They can successfully recycle about 10% of it, and the rest is just managed disposal. I really want you to remember that our electronics come at a very significant cost, not just making them and extracting them, but disposing of them. We should really ask ourselves just how much we need these. I am an Apple addict. I'm on my third iPad, my second iPhone, my fourth iMac. I've had 2 Power Macs. I've had 3 Apple laptops. Oh yeah. I've gone through 1, 2, 3. I'm on my 3rd and 4th iPods.
Apple TV.
I have an Apple TV at home and an Apple TV here in the classroom at 2 airports. That's just one brand. And before that, I had other electronics. My family's awash in electronics because my dad works in technology. Okay. This raises a lot of the issues. Not just what are the costs of getting it out of the ground, but what do we do afterward? How much can we reuse? How do we put it in the ground when we can't use it anymore? And so, quickly, I'd like to do numbers 20 and 21. The evolution of waste management and integrated waste management.
Does Apple work if you break the phone, like say you just shattered the screen or something like that, and they take it and give you a new one? Do they just replace the screen and give it back?
Some is refurbished, much is wasted or recycled. Oh, by the way, we could also demand that our technology makers make things more easily reparable and modular. It's just that that's not as sexy of a design. Google just announced that they're going to start making an Android phone that's modular. So they will sell you the skeleton that accepts 8 modules.
That's awesome.
And so you can replace the battery, you can replace the screen, you can replace the processor, you can make it Wi-Fi only or cellular only or both. And obviously, instead of throwing out the whole phone, you just replace the parts and you keep the 7 out of 8 pieces that are still good. So instead of switching phones, but they're facing a lot of uphill competition. The public doesn't like that. The design is kind of clunky, you know. Okay. So number 20, the history of waste disposal. In the Industrial Revolution, like 1800s days, there weren't a lot of people around and there wasn't a lot of garbage. So the philosophy was, quote unquote, dilute and disperse. Meaning spread it out and get it away from you. Back in the day, our garbage went in the river, went out on the surface so the wind could fly it away, went into the ocean so the water would make it disappear. And as we've added more humans and as our trash has become bigger, it started coming back to us. Throwing it into the environment started making problems. So by the early 1900s, as our cities were getting bigger, we started to put everything in landfills. The idea was, hey, wait a minute, concentrate and contain the garbage. Rather than putting it into the environment and seeing it again next week, just say, fine, Jackie's house, that's where all the garbage goes from now on. And you pick a place and you throw it all there. Convenient location, middle of everything, keep all the garbage in one spot, concentrate and contain. And this is largely what we do around the world, except in some places we're starting to see problems. Like in places where economies are old and changing. Because imagine, Gabriele makes paint. In the 1920s, he's starting to get old. And so before he dies in his golden years, he leaves it to his granddaughter, Maddie Cutler, in the will. Maddie Cutler doesn't have much interest in the paint business. The factory was kind of run down. By the time she gets around to signing the papers, they're out of business anyway. So she kind of sits on it for a while, and when she's pretty old in the 1960s, as a way to lower her liabilities and get a tax benefit, she donates the rusted carcass of the Reale paint factory to the city of Santa Barbara so that they can have some land later. And the city of Santa Barbara through the 1960s and 70s is overwhelmed with other projects. They just keep the dirt as, someday we're going to do something with this. But the fire/earthquake/flood obscures the records of what used to be there, and the barrels get kind of rusty and pushed into a corner and overgrown with weeds. And vagrants light the building on fire, and they had to demo it. And by the 1990s, it's not really clear what the hell used to be there and what the hell is still there and what that old, crusty, dangerous building is. So the city demos all of it and sells it to Hannah Antrim, who built a preschool there. And 10 years later, Santa Barbara's full of blind kids with mental retardation and cancer. I'm glad that you're all entertained by this. And I don't know why you blame Hannah. All she did was build a preschool. She didn't know. And you can't blame Gabe because he never broke a law in his life. And you can't blame Maddie Cutler because what's she supposed to do? She just inherits a business that she doesn't know anything about, and she donates it out of the good of her heart, just being a nice citizen. And you can't blame the city of Santa Barbara. They're just trying to keep all these things in the air. And disasters happen and records get lost and the labels fall off the barrels and they get rusty and they leak, and that's nobody's fault. But the United States is now full, like many developed nations are full, of abandoned industrial sites with hazardous pollution called, vocab, brownfields. Abandoned industrial commercial sites with hazardous pollution. Abandoned industrial commercial sites with hazardous pollution. Brownfields are actually really scary because they're just dirt that's nobody's responsibility in particular. We can't afford to clean them up, and we're not really clear what the contamination is. We laugh about the school thing, but that's exactly what happened at Love Canal. A whole generation of people there grew up with elevated cancer risk. Because I don't think it was paint, it was some sort of chemical though. Because the school site had previously been used for some forgotten polluting business. The land was mismanaged and got kind of nasty, whatever. Sometimes, but it's very difficult to do that. So anyway, in this history of waste management, we've come to realize that we've got nasty consequences to our electronics and nasty consequences to many of our businesses. And no matter what you try to do with the trash is a problem. So our future, the goal for your generation to dial in, is what's called the zero waste material economy. Where instead of making garbage, we find a way to turn things back into something else that's useful, just like nature does with everything else. There's no trash in nature, it's just all recycled somehow. The zero waste economy is to do the same thing. And by the way, that makes sense economically, and it makes sense socially, and it makes sense environmentally. This isn't some hippie propaganda, it's good for everybody. The best way to do this, number 21, is to manage all parts of the waste stream. It's called integrated waste management. Many different methods to keep waste out of the landfill. Get as little as possible into the ground, divert away from the landfill as much as possible. We'll pick up here tomorrow. Goodbye.
What do you want?
Travis, it is.
I can do it, because I don't know how to unlock it. You can do an emergency call to my number.